I wonder how fast these can fire. Oh! 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 It worked! It worked! Do not shoot. Do not shoot. When the hand is here. Oh, there it is. Work, demon. No. Oh! Put it all together and it worked. It is done. There's a quick schematic. Here's the code. No delays in here either. It also automatically corrects for ambient light differences and scales all the time, so you never have to worry about doing that yourself. I can explain it. Essentially, it is checking the first sensor input all the time, and we're using micros for higher resolution. It's looking, it's looking, it's looking. While it's looking down here, every second it steps into the calibration code right here, which just asks what's the resting voltage on the two sensors. All right, whatever that is, subtract 2 from that and make that the cutoff for when the sensor's active. So it's swinging by maybe 6 millivolts or 3 millivolts when the airsoft BB goes by, and yeah, it's about as good as you can get with a 10-bit ADC. Now, if the sensor up here is fired, and essentially it where's that if statement? Here it is. If IR1 is less than the cutoff, which was determined by the calibration code down there, then we step into this if statement and we switch over to start the time. So tx is 0, tx is equal to micros minus t, so whatever the time was out here, it doesn't really matter because it's subtracted off here. So now we start the clock and we're looking at the second sensor. We're looking, and as soon as that second sensor is detected using the same edge the calibration code gave it down there, we say, hey, all right, what time is that? Awesome. If the time is reasonable, which I deemed to be about 350, which is equivalent to about 1,000 feet per second, or maybe 1,200 feet per second, display data. If it's unreasonable, so if the time it took for it to travel is more than this 350, then just don't display data, basically, because it doesn't really matter. Yeah. So if it's more, no, I'm sorry. So if TX is more than 350, display data. If it's less than 350, don't display data. Don't need it. It's an outlier. So that's kind of how we're going to filter the really weird signals, because there's some weird stuff that happens. So, and this while statement will expire in 3,800 microseconds, and when that happens, it dumps you back into the normal code, and it gets ready to wait again, and it keeps calibrating all the time. Now, if we got good data, and we did, we're going to take the time, we're going to take our length of our the distance between our two detectors So we know how fast, we know how long it took for this thing to travel a known distance, which is about 12 centimeters. Instead of multiplying in for the micros and complicating it, I just already multiplied it to the distance. So I took 0.1226 meters and I multiplied it by 1,000,000. And now we have 1,000,000 in here, and we can just divide straight by tx. And that will give us our meters per second. And meters per second times 3.28 is feet per second. And we can say, hey, display all this data. It's really cool. We have our miles per hour, which is feet per second divided 1.66, because 60 times 60, and then 5,280. It's all happy. And we come down here, and it's basically going to wait 2 seconds so you can see the data. Really cool. And in this little while statement, and then it bumps out of here, and we're back into the normal SOP, where it's just calibrating and waiting for a firing signal. So yeah, that was pretty cool. Gave me some challenges, but we got her. Oh. It's not the prettiest thing ever. Made it in a day though. Well, actually made it in half a day. I would want to solder all this together. You can recharge it right there with that micro SD. This battery is just laying around. We got the 2 sensors here wired together. Got a capacitor I fit in there, and we can still get through to there. And we got our LCD screen. Now the way we work this is there's this cute little button, and you hit that, it turns on, and that counter is coming right out of the calibration code, so every time it ticks, it moves to the calibration code by 1. There's a very slight chance you could fire while it's in the calibration code, but it'd be very hard to do that. So anyways, and you let go of the button, turns off. Alright, let's just work on the first try. Of course. There we go. 180. That's not right. Alright, I got it to work like 3 times. Yeah, it's certainly not perfect. Ah, shit, we're out. Alright, gas blow back. This one can get up to like 500 or 600, maybe even 700. Yeah, what was that? 705? 500. See. Ghost in the machine. There's no bolts in here. Alright, Stu, new rifle. Hook it up. There's one. 442. 442. That's what I have to see. 442. Yeah, yes! It likes this boy. That's also pretty good for a rifle. Woo. Hell yeah. Hope you guys found this interesting.